So today we are looking at topic 2. Functions. In functions, the first thing that you talk about before functions is derivations. So you first discuss derivations. Because a function is a relation, so it's coming from the family of relations. Now we have four relations. The first one being in this form. So I'll demonstrate them using arrow diagrams. Suppose we call this set X, this set Y, and then we put some number here, 1, 2, 3, 4, 7, -10, 0, 8. Then we'll have a relation, we'll have a map that gets numbers from X, taking them to numbers in Y, like this, like this. So a relation of this nature is going to be called one-to-one relation. Then the second one is if I have 1 here, 2, 3, then I have 4, 7, then 3 goes here, 2 comes here, and 1 goes there. We'll say many to one relation. And then the third one, we have 0, -1, -7, 2, 1, 3, 4. And then we have this guy here, this guy here, this guy here, and this same guy here. Then we say one to many direction. And then the fourth one, you have the relation, these two maps, A, B, C, D, E, F, A. So this one goes here, and the same one comes here. This one goes there, and then this one comes here. Let's say this one comes here as well. So we have many to many, relation. So now we have 4 relations. That we'll talk about. As you can see here. So then our target is to check which of these relations are functions. So then for us to check, we must have a definition of what a function is, so that we just go there and check using our definition which of these relations is going to be a function. So let us define a function. So the definition of a function. So we say a function is a relation in which
asking for the previous one.
okay, we'll be there soon. So a function is a relation in which each element of the domain is uniquely mapped to an element of the codomain.
Sir, excuse me, I can't see the screen.
Are you now able to see the screen?
Able to see.
Yes.
Okay. So we are saying a function is a relation in which each element of the domain is uniquely mapped to an element of the codomain. So each element of the domain is uniquely mapped to an element of the codomain. So if we go back to the relations, we'll notice that the first one, each element is mapped. And since there's only an arrow from each element, then we are saying each element is uniquely mapped. So the first one is a function. So this is a function. The second one, each element of the domain is mapped. So this is the domain, and this is the range. So each element of the domain is mapped to an element in the range. And each element is only mapped to one element on the right. Each element of D is mapped to only an element of R. So it is a function. Three, we have 7 that is mapped to 2 elements. So it's not a function. 4, we have A mapped to 2 elements. We have C mapped to 2 elements, so not a function. So here now we are saying the domain for this set is 1, 2, 3, 4. And the range for this set is -10, 0, 7, 8. The domain for this function is 1, 2, 3. The range for this function is 4, 7. Like that. So we're only able to find the domain and range of functions, not just any relations. So we won't talk about 3 and 4. So now, if we get to some more examples after we've defined what a function is, then let's see the example here. So the first one, using arrow diagrams, determine which of the following are functions. Find the domain and range of the functions. State their inverses and the domain and range of the inverses. A, we have a relation (1, 2, 0, 3, 2, 3, 7, 8. B, G, -1, 0, -3, -1, 0, 4, and 1, 8. And then C, H, then -10, 0, 2, 1, -10, 3, and 7, 0. Solution for A. So using arrow diagrams, so first we make arrow diagrams for F. So I have the numbers I did a lot. So using arrow diagrams, determine which of the following relations are functions. Find the domain and range of the functions, state their inverses, and the domain and range of the inverse. So let's start with A. So A, the x coordinates. The x coordinates are the numbers that we take in the domain. The x coordinates without repeating any. So we have 0, 1, 2, 7. Going to 2, 3, 8. So not repeating any. Then we'll have 0. 0 goes to, so 0 goes to 3. 1 goes to 2. 2 goes to 3. And 7 goes to 8. So all the elements of the domain are mapped by F to an element on the right. So each element of the domain is mapped to an element on the right. So we are saying this is a function. It is a function. Then find the domain. So what's the domain? The domain here is 0, 1, 2, 7. Find the range. The range here is 2, 3, 8. State the inverse. So F inverse is equal to, so for the inverse, you just switch. What was the y coordinate? You make it an x coordinate. An x coordinate, you make it a y coordinate. 3, 0, 3, 2, and then 8, 7. 8, 7. Okay. Then the domain of the inverse is going to be 2, 3, 8. The range of the inverse is going to be 1, 0, 2, 7. So what we want to see here is seeing that, oh, the domain for F and the range for F. So the domain for F is actually the range for F inverse. And the domain for F inverse, I mean the range for F is actually the domain for F inverse. So we are saying, we note that the domain for F is the range, the domain for F is the range for F inverse. And the range for F is the domain for F inverse. It's from this note that we generalize. If you are given a function f is equal to 3 over x minus 1, then we say find the range of f. The easiest has been you get the inverse of f, and then its domain will be the range of f. So the domain of this will give you the range of f. It is coming from this analysis here. So the arrow diagrams will help us easily understand the relationship here, so that when we go where we cannot form an arrow diagram, then we should be able to use this same statement to be finding the inverses, I mean to finding the range of inverses here. That's how it's going to be.
Kindly repeat on the function side. I don't get the concept there.
Okay, so on the function, what do you mean on the function?
How we are trying to interconnect the domain of the function and the function you've written 3 over x minus 1.
No, so
How
here
we are
we're
trying
saying,
to interpret.
here we're saying because we've come up with this relationship here that the domain of f is the range of f inverse. The range of f is the domain of f inverse. The term will be given a function f, and they're asked to find its range. What we'll do is we'll get its inverse and then get the domain of the inverse, because it's equal to the range of f. That's the point there. So that one is coming soon. So we'll see, and then we'll demonstrate on how that is happening. So you go to B, we're given the function g, -1, -3, 0, 1. Find first an arrow diagram and then the domain. So for B, we have an arrow diagram here. It is found. So we have -3, -1, 0, 1. And -3, -1, 0, 1. Against -3 goes to -1. So we have -1, 0, 4, 8. -1, 0, 4, 8. And then -3 goes to -1. -1 goes to 0. So -3 goes to -1. -1 goes to 0. And then 0 goes to 4. 0 goes to 4. 1 goes to 8. Clearly, this is a function. So G is a function. Now, after G is a function, then we get its domain. The domain of G is -3, -1, 0, 1. The range of G is -1, 0, 4, 8. And then G inverse is -1, -3, 0, -1, 4, 0, and 8, 1. So to form the inverse, you start with the numbers on the right and then pick the side. So this becomes our X coordinate, this becomes our Y coordinates. That is for G inverse. So you just start with X, Y. Now your X becomes the Y. So just switch the coordinates. Then the domain of G inverse is simply equal to the range of G, which is -1, 0, 4, 8. And the range for G inverse is simply equal to the domain of G, which is -3, -1, 0, 1. Okay. We go to C, the arrow diagram. So C, we have -10, 2, 7. -10, 2, 7. And then we have 0, 1, 3. 0, 1, 3. 0, 1, 3. Then we have -10 going to 0, -10 going to 3. So -10 going to 0. Let me make my work a bit nice. -10 going to 0. The same -10 going to 3. And then 2 going to 1, 7 to 0. 2 going to 1, 7 going to 0. So because of 10, that is mapped to 2 elements on the right, this is not a function. And because it's not a function, we won't even bother to start talking about the domain of variation that don't even understand and about the range. Okay, so this is how you find the domain, the range, the inverse of such functions. So we now talk about the composition functions of these. The composite functions of ordered pair functions. Okay, so we'll go straight to examples here. Find for one, find a f of g, a b, a g, f of g inverse, c, g of f, and the domain and range of each function, of each composite function. We're given that f is 0, 1, 3, 4, 7, 8, and 9, 11, and g is 1, 3, which is 8, 1, 11, 7, and 4, 9. Like that. So let's see the solution. For A, we want to find f of g. So for f of g, this is how we proceed to finding f of g. You have f, so you have f, and in f, where there is x, you put g. So what is happening is, if I have a number x is equal to 2, this number will first go in g. So I'll have g of 2, and then get a value here, say 4. So that where there is g now, I will have the number 4 because I know what g is in value form. So when we go to f of g, we are starting with g. So you come to g and pick 1. So you pick 1 in g, and then g of 1 is equal to 3. So f of g of 1 is the same as f of 3. So we go now to f and pick 3. It's giving us 4. So you put 4 here. So this means that f of g of 1 is equal to 4. So for you to get to 4, you first have to evaluate the g of 1, get a number 3, then this 3 now is what you take in f, it has given us a number 4. Next, we go to 8, you get this 8 in g. So now we have f of G of 8. G of 8 will give us 1. So we now have f of 1. F of 1. So there's an oversight in our function. So let's see. Oh, okay, this one's supposed to be 0. So this is supposed to be 0. So that f of, so we restart this one. So after I put 0 there, then now we have G, so f of G of 8. This is going to be f of G of 8 is 0. So now we have f of 0, which is equal to 1. So we put a 1 here. Okay. Then next we get 11 for G. Then we get f of G of 11. So G of 11 is 7. So G of 11 is 7. Then what is f of 7? F of 7 is 8. So we get 8 there. And then we go to 4. So G of 4 is 9. And then f of 9 is 11. So this is f of G. And then we are told we should find the domain. So let's find the domain of f of G. The domain of f of G is 1, 8, 11, 4. The range of f of G is 1, 4, 8, 11. And then we go to B. B, we get f of G inverse. So f of G inverse, we already have f of G here. So its inverse, just switch the coordinates. So 4, 1, 1, 8, 8, 11, and 11, 4. Hello.
Sorry for inconvenience. Actually, I don't know what you are doing. They're doing on f of G. I don't know how we are trying to evaluate because the concept I have, I think they are not matching by far. So I got lost.
So you have the wrong concept.
Definitely.
Charles is roasted too. Okay. So here, maybe let me pack this a bit. I do a very simple one. If g of x is equal to x plus 1 and f of x is equal to 2x, when we say find f of g of 4, what we are saying is evaluate f of g of 4. So you can get this 4, bring it to g. So you have g of 4. You get 4 plus 1, which is equal to 5. So that where there is g of 4, what we have is 5. So you can put a 5 here. Then this 5, you take it now to f. F of 5 is what? It's 2 times 5, which is equal to 10. Or you can find f of g. F of g, where there is x in f, you put g. So you have 2g. But g is known, it's x plus 1. So you get 2x plus 2. Then now we're saying find f of g of 4. Then you have 2 times 4 plus 2. This will be 8 plus 2, giving us 10. This number 10 here, this number 10 is the one that we got even here. So what you're doing here is we're evaluating the function f of g, except that here already given the results. Like if you want to evaluate it in g first, the number is already given. When I take 0 in g, when I take 1 in g, I get 3. So if I want to do g of 1, then I'll just pick the 3. Then I move with it to f. F of 3, I'll pick its 4. Then I have this pairwise coordinate. That's why we are picking this. So now your task will be, as you try to see what is going on here, you have to understand and do which one? Do C. Find G of F. So I give you the domain. G of F is going to be 0, the number you get, 3, the number you get, and 7, the number you get, and then 9, the number you get. So the domain of this is always the domain of F. You just pick all the F's, they now start looking for their corresponding. Like the first one, so you have G of F. So F, we pick 0. Where does F take 0? It takes 0 to 1. Then you go to G with your 1. What is G of 1? G of 1 is 3. So you put a 3 here. So you keep going until you finish this one. Then find the domain and the range of this function. Find the domain of G of F, the range of G of F. So at 19 hours, we join again. So we have 10 minutes to see what was going on in this. Then we'll do some more examples and close the composite functions here on these ordered pairs.